In setting up any system infrastructure, resources like CPU, RAM, and storage plays a very important role. These components are crucial for the performance and reliability of any system. We will explore each of these in detail. My name is Asadullah Malik and I welcome you to my channel Tech World. Let's get started with the first video of this series. Before diving into the details, it's important to understand how the CPU, RAM, and storage work and are managed. First, data is stored in storage as a program. When the program is opened, it is loaded into RAM and become a process. The CPU then perform computational tasks on it and send the result back. Once the process work is finished, it is saved back to the storage. Now the question is who is managing all this, deciding which program need to be loaded into RAM, require CPU time, or need to be stored in storage. Because if they run independently and directly access resources, the CPU would lack direction for managing processes. RAM management would be difficult. There would be no system to allocate memory to different programs, leading to potential data corruption. File system would not be managed, making it difficult to store, retrieve, and organize data. The operating system is there to manage the CPU, RAM, and storage to ensure that your system operates efficiently. It plays a critical role in coordinating these components to maintain smooth and effective operation. Programs are stored on storage. When user click on a program, for example Word, the OS locates the program files on the storage device and loads them into RAM. It sets up necessary data structure to manage the program as a process. The OS creates the process for application, allocating CPU time and RAM space and schedule it for execution. It ensures CPU execute the necessary instruction to process user input, update the display, and handle other required tasks. The OS continuously manages RAM, ensuring that the Word and any other running program have the necessary memory. It may swap out inactive parts of program to virtual memory to free up RAM for active processes. The OS manages hardware resources, ensuring the CPU, RAM, and storage work together seamlessly. It handles the write operation by transferring updated data from RAM to storage, ensuring documents are saved correctly and securely. This enables users to run multiple programs efficiently and effectively. Now that we understand how they function, let's start with the CPU first. CPU stands for Central Processing Unit. The CPU is the brain of the computer. It is attached to the motherboard and is responsible for executing instructions. Understanding these components is crucial for optimizing server performance and ensuring efficient operation. A CPU socket on the motherboard is a physical connector for a single CPU. Servers often have multiple CPU sockets, allowing for the installation of multiple CPUs on one motherboard. The CPU installed in the motherboard socket executes instructions, runs applications, and handle multiple requests designed for high performance and reliability. Each CPU contains multiple cores that process tasks simultaneously, enhancing system performance and efficiency. These cores are individual processing units within each CPU. Modern server CPUs have many cores, allowing them to handle numerous tasks simultaneously. A thread, often referred to as a software thread or execution thread, it is the smallest unit of execution that a CPU core can handle. A single core can manage two or more threads concurrently, depending on the hardware manufacturer, enhancing the server efficiency and performance. A CPU cycle or clock cycle is the time taken to execute operation like fetching, decoding, executing, and storing an instruction. The speed of these cycles is determined by the CPU clock speed measured in hertz. Modern CPUs have a clock speed in gigahertz, where 1 gigahertz equals 1 billion cycles per second. By looking at the example, this means a single core can execute 2.6 billion cycles per second. Clock cycle can vary in efficiency. Some instructions from one CPU can be completed in a single cycle, while another CPU may take multiple cycles to complete the same instruction. A newer CPU with a lower speed can outperform an older CPU with a higher clock speed due to more efficient architecture. Do not rely on clock speed only to measure efficiency. For overall efficiency, refer to the hardware documentation of specific CPU. In a server environment, cores and thread maximize processing efficiency by executing tasks in parallel. For example, if a core supports a single thread task on that core do not execute in parallel. But if each core has multiple threads, it can handle them simultaneously, distributing the workload evenly and ensuring the server can process a high number of requests at once. That's complete our section for the CPU.